Okay, so we're up to number 22 in our pre-calc review packet. This one's a little trickier than this one. It says find the approximate area of triangle ABC if side B is 12. Got all this stuff labeled right here. And so if we look through our options, we either need to know side A, side B, and angle C. See, we got side A and B, we don't have angle C, and there's no way we can, it's not something we can just quickly arrive at. Same thing here. We don't know side C, and we don't know angle B. Here, we don't know side C, but we do know angle A. So somehow we're going to have to figure out one of these things. And what I'm going to look at is this. I know angle A and I know side A. So I'm going to take a stab at the law of sine and go sine of 115 over side A. And now because I know side B, I'm going to go sine of angle B all over side B. Now I'm going to hit pause and calculate some things. And so what I needed to do is just figure out what sine of 115 was, and it's 0.906. So now I just need to multiply that by 12, and I get 10.85. We'll call that 10.9. So 10.9 equals 20 times sine of B, because I'm going to multiply that way. I'm going to divide by 20, divide by 20. Give me a second. So now that I have this, I calculated 10.9 divided by 20, 0.54. Now I'm going to go second sine, 0.54, enter, and I get 32. We'll just call it 32.7 degrees equals angle B. So if this is 32.7, see, now I can figure out what this is, because I can go 115 plus 32.7 is 147.7. If I subtract that from 180, I can see that I'm going to get 32.3. See, now that I know all the angles and two of my sides, I can for sure use one of these formulas for the area over here. And so that I know, because I know side A and because I know side B, I'm going to use this guy with angle C. So my final step would be 1/2 side A, which is 20, side B, which is 12, and sine of angle C, which is 32.3. So I got to figure out what all of this is. All right, so what I did was I figured out what sine of 32.3 was. It's 0.53. Remember, I'm rounding. And then I figured that 200 times 12 is 240, times 1/2 is 120. 120 times this is 64.12. And I panic a little bit because I don't see anything really close to that. But because we rounded and because these other answers are so far apart, I can be pretty secure in 22 being B, 64.12. Remember, we rounded a lot in this problem. That's why we didn't. And it does say the approximate area, so we can relax a little bit. All right, on to number 23. Okay, so on number 23, I know that I need to go to my Unit 3 formulas. And what they start you off with is 1 minus cosine squared to figure out. Remember, huge clue, 99.99999% of the time you don't mess with sine or cosine, which is drawing your attention to this. And so you go through your formulas, and I'm just going to quickly have you come down here. And I know this is close, but it's not a perfect match. But if I subtract cosine squared from both sides, I get sine squared equals 1 minus cosine squared. We talked about this when we covered Unit 3. So I take this out, and I replace it with sine squared theta over sine theta. And don't let your brain go into overdrive. X squared over x is just x. So sine squared over sine is just sine. And we go to our answers, and we can see that that's letter E. And now that we jump to number 24, we can clearly see that this is what we need to find somewhere. And if we look down here, and just remember pi over 2 is the same thing as 90. And so we look for where is sine pi over 2 minus theta, and it's right here. So what does this little mess equal? It equals cosine. So we're going to replace that with 1 over cosine theta and hope that this is one of the answers they give us, and it's not. Now somebody might be tempted to circle this, but these are not the same thing. So you have to ask yourself, what is the reciprocal of cosine? Well, that would be secant, and that's why letter E would be your correct choice in this problem. So for number 25, we've got something else we're asked to simplify. Remember what I said, don't mess with this, just leave it alone 99.999% of the time. Don't mess with sine or cosine, which is drawing your attention to this. So step 1, I would recommend that you look for this exact thing. And if you look down in here, see it's clearly not going to be here because that just doesn't even look right. But we have some options right here. And if I see cosecant squared, draws my attention to this. Now you can see this is cosecant squared minus 1, so if I subtract this 1 to the other side, I could rewrite it like this. So I know cosecant squared minus 1 equals cotangent squared. So I'm going to take that out, and I'm going to go sine squared x times cotangent squared x, or theta, whichever one you want to use. Now, we look for that option, but you can see it's not there, which means you got more work to do. Now, what is cotangent? Well, if you look at cotangent, cotangent is cosine over sine. Well, this is cotangent squared, so all you need to do is kind of just plunk those squareds in there, and now you have a true sentence. So I can replace cotangent squared with this, which at first it looks like you're just making it worse. But then if you look for a second, when you multiply fractions, you cross-reduce, and then you swoosh. So there's my answer, and that is option A. Okay, number 26. Looks like a very intimidating problem, but it directs your attention. It says use the sum or difference identities. And so here's the trigonometric sum difference formulas. Another word for formula is identity. So we just kind of look and we say, hey, what does this one look like? Well, there's a plus, there's a plus, there's a minus, there's a minus. This one has it reversed. That's a minus and a plus. So we don't want to use this one. We want to use this one. We want to go from this direction back here. So it's just saying, take the u, which is the first one always, pi over 3, and add it to the v, which is the second one, 7 pi all over 8, and then just simplify it. And as you can see, they're going to force us to find common denominators. So that's just going to be 8 pi over 24, plus, if I multiply both top and bottom by 3, I'm going to get 21 pi over 24, which is 29 pi all over 24, which is awfully strange looking, but there it is, letter D. Somewhat similar to the previous problem. This one's saying use the double angle identities, and you can see it says double/half formulas, identities, another word. And so what we have to do is look for this thing. What looks similar to this? And my eyes go right to here. So 1 minus 2 sine squared u. So that's saying that u equals theta over 4. And then you need to go from this direction that way. That's how we're going to simplify it. So this formula just says, turn this mess into cosine. That's what this means. And then double your u. So we got to go 2 times theta over 4, which reduces to cosine of theta over 2. And that would be option A. All right, so number 28 gives us some instructions right away. It says use the sum or difference formulas or identities to evaluate this mess. So we kind of have to ignore the 220, the 10, the 220, the 10, and just look for where we can go cosine, cosine plus sine, sine. And here it is, cosine, cosine plus sine, sine. And then we go this way. And it's saying to simplify it, you turn it into cosine. You take the first degree measure, which is always u, and you subtract the second one. And we get cosine of 210 degrees. Now here's the deal. As you can see, this is not an option. So it's saying to us, keep going and figure out exactly what it is. Looks like they gave us some calculator ready problems, so you might be able to type in cosine of 210 and say a prayer and hope it's one of those. So let me show you what I mean by that. And we might as well do it if they give us that as an option. So cosine of 210, enter, and I get negative 0.866. So as you can see, that's not one of these options. So they're forcing us. You could kind of figured they would do that, but you got to spin your spinner 210, which is right here, which means this is 30, this is 60, this is negative 1, this is negative square root of 3, and this is 2. And so what is cosine? It's adjacent over hypotenuse, which is negative square root of 3 all over 2, which is option D. Okay, so number 29 is saying use the sum or difference identities to evaluate sine of 255. This is that problem where I said you need to make sure you have reference angles that are 30, 45, or 60. Now that doesn't mean you pick these necessarily. As you can see, you need to pick two that add up to 255, or by subtracting them ends up being 255. Now what jumps out at me is, if I take away 45 from this, I'm going to think of it as 210 plus 45. Now someone else could go sine of 45 plus 210, but I chose this way, so this is my u, this is my v. The other student, this would be their u, and this is their v. You'll get the same answer regardless, but it does give you a hint. It says use the sum or difference identities. We're going to use the sum because these are pluses, and I have sine of u plus v, which is right here. So this is the formula I'm going to use for this problem. So it's sine of u cosine of v plus cosine of u sine of v. And I've got some work to do. So I need to give myself a little 45, 45, 90, which is right here. I also need to get my 210 picture going. So that's 180 plus 30, which is negative 1, negative square root of 3, and 2. And now I can figure out all this stuff. So what's sine of 210? Opposite over hypotenuse, that's negative 1/2. Cosine of 45 would be adjacent over hypotenuse. That'd be 1 over the square root of 2. I'm just going to keep moving down the line here. Cosine of 210 would be adjacent over hypotenuse. Sine of 45 would be opposite over hypotenuse. And now it's just an algebra nightmare. So we multiply these together and we get negative 1 over 2 square root of 2 minus the square root of 3 all over 2 square root of 2. Now as weird as this looks, notice we have common denominators. So we can write this as negative 1 minus the square root of 3 all over 2 square root of 2. Unfortunately, as you can see in all of our answers, they're not going to let the square root stay in the denominator. So we're going to multiply the top and bottom by the square root of 2. Now this guy would bounce through there. So we would get negative square root of 2 minus the square root of 6 all over. Now the square root of 2 times the square root of 2 is 2. 2 times 2 is 4. So I go on the hunt for this. And that thing would be right there, letter D. Now number 30 doesn't require any formulas. It's just asking you to solve it. So I'm going to subtract the square root of 2 from both sides. So I get 2 cosine x equals negative square root of 2. Divide by 2, divide by 2. And I get cosine of x equals negative square root of 2 over 2. Now don't forget this. All students take calc. As you can see, we have more than one option for our answers in each choice. So where can cosine be negative? Not here, because everything's positive. Cosine's positive here, so it would have to be quadrant 2 or 3. Square root of 2 is telling us it's very, very likely that it's a 45, 45, 90. With my adjacent side, negative square root of 2, hypotenuse 2. Whoopsie, that's just a 2. And then I have the same situation here, where this is a 45, 45, 90 with my adjacent side, negative square root of 2, hypotenuse 2. So one of my answers is 135, and the other answer would be 225. and you have to convert those to radians, which would be D.